Hey, John here. Let's talk about friends, all right? In C++, a friend is something somewhere that allows code to violate this privacy concept. When we talked about class, we talked about the private parts of a class and the public parts of a class. And I recommended at that time that all member variables of all classes should be made private if they're mutable in any way. I mean, if you have a constant or something like that no one's allowed to change, then you could make that public if you wanted to, because then you don't have other functions or users somewhere in the future that use your object, pulling the rug out from under your feet by reaching in there and changing values, possibly setting them to illegal values. The friendship allows access to be granted to certain functions or classes such that they can go in there and interact with the private parts, okay? So let's look and see how this thing works. There's a couple of new things in this video. The idea of just declaring that there shall be a class called Baz. This is no different than any other thing you can do in a header file, really. You can say like int func of int, x, like this. What does that thing do? Well, that just simply states to the compiler that there will be a function called func, I should say, that takes an integer parameter and returns an int. You have yet to define it, but you can declare that it shall exist in the future during the compilation process. There's nothing wrong with this. And it applies to classes as well. It just simply says there will be a class called Baz. Now, this is the same foo that we saw before, minus some extra functions that we're not going to use in this example. They don't have any value to be here. They will only use up space, so I removed them, all right? So what are we left with? We're left with a couple of constructors, the destructor, a mutator, an accessor. We're not even going to use these in this discussion. And this new concept here, friend Baz, okay? This is why we had to declare that there will be a class called Baz at some point. And by saying friend Baz in here, what we're really doing is telling the compiler, look, make the entire class Baz and all of its methods a friend of this foo class. And because they're a friend, that friend is allowed to have access to the private parts of foo. So let's look at the class Baz down here. We have got some private variables called A and B. We've got a usual constructor, a nice default constructor here. We have a method called tinker that takes a double and a foo. All right. Now, I don't know if you've seen this before or not. We don't have to declare the names of the variables in here. They're not relevant at this point, okay? So you just have to have the types in here, okay? Later on, we can then define the tinker function down here, or I could have made it inline up here in the class if I wanted to, all right? And the Baz class here is going to declare that a func1 is going to be a friend of Baz. Now, func1 is not a member function of Baz. It is just a regular old function. You can see that down here. We know this is not a member because it doesn't have any membership stuff in front of it like this does. This Baz ; tinker, this makes tinker a member of Baz. All right? This has no membership of anything. This is just a regular old run-of-the-mill function. However, we've declared that func1 that takes a reference to a Baz and returns an int is a friend of Baz. So if we look down here in func1, we're passing in a reference to a Baz, and func1 is free to reach inside and grab the private parts of Baz if it wants to, right? This A and B down here. So I can write this function that's not a member of Baz, but it still acts kind of like one in that it has access to all the private parts of Baz. All right, so it can do this. It can even return them so that the caller can grab the value of the A member of Baz without even using a member function of Baz. Okay. The method up here, since all of Baz and all of Baz's methods are friends of foo, and we're giving it a pointer to a foo, it's okay for this member of Baz to reach over and grab A from the private parts of foo. Now, this is commented out. I'll turn that back on in a minute to show you what happens when you're doing things you're not supposed to be doing. Let's see what's going on in main here. What do? We create a foo and we give it the A and B values in the constructor that takes these parameters. We create B with the default constructor. Let's review really quick. The default constructor of Baz here simply allows the A and B to be set to 1, 1, 1, 1 and 2, 2, 2, 2. And we've seen this one up here before. This constructor in foo allows me to set the A and B variables to override these defaults, which are null here, okay? So it creates the foo with 1, 2, 3, 4, and 5, 6, 7, 8 for the values. It creates B, and the defaults will be 1, 1, 1, 1, and 2, 2, 2, 2. We're going to call B tinker, and we're going to pass it this double value and the address of F, because that's what it needs to run, right? A double and a pointer to a foo. And we're going to just print out the double. The double doesn't mean anything. I just threw it in there to let you know that don't memorize this and think you have to pass a pointer to this other function, right? Down here, I'm passing in a reference. It doesn't matter what other parameters and stuff you have in here. If Tinker has access to a foo in any way, shape, or form, it can reach in there and interact with the private parts is the point. Okay, so I'm going to call Tinker. And then I'm going to call func1, and I'm going to give it a reference to B, I guess, right? Because func1 wants a reference to B, and we'll see that both of these this will compile and run. I guess I already compiled it. All right, so let's go ahead and run it. What do we got here? We're going to construct a foo. We've seen this before. I print out the address of this in these constructors so we can kind of see what's going on. So foo is constructed, and it invoked the one that takes the two integers. Baz is constructed using the default, the only constructor I provided. We then call tinker on the Baz function, and we pass it a double, which is not used for anything. We just simply print it out. But this is the interesting thing. We can print out the A variable of the foo object. We can reach right in there and grab it and print it out if we want. We then called func1 and passed it a reference to B. And func1 was free to reach in there and grab the value of A if it wanted to. We see the destructor of foo running. We do not see the destructor of Baz, probably because I didn't put one in there. Yeah, I didn't define a destructor in here. Therefore, it used the default destructor, which does not print out anything. We don't need to get into that. Okay, so this demonstrates how things work when they're defined correctly. What if they're not defined correctly? Well, let's turn this thing on. Look and see what's going on in here. I got a func2. It takes a reference to a foo and a reference to a Baz. All right? And what do? I grab I use the foo reference to grab the value of A, and I use the Baz reference to grab its value of A. They both have an A member function, and I try to return the A member of Baz in here. This is basically the same kind of logic that's going on up here in func1. However, func2 is not a member nor friend of anything. So when we compile this, we're going to get all kinds of errors. Error. Foo A is private within this context. You can't touch it. On line 83 of friends.cc. So let's go to line 83. This is line 83, so it's saying I can't do this. I can't do it in this context. Why? Because func2 is not a friend nor member of foo. And the next error will probably be this. We look down there, there's 83, and then it says, it talks about the A and where and how and why it's declared as private. Then it moves back onto line 83, and it says what? It can be accessed via this if you would like to. Look at that. Compiler's helping you enormously. If you really want to get the value of A, wow. It gives you this hint. This is actually quite impressive. I didn't realize that it would be this smart. I guess it can be. That's a pretty trivial accessor function here, if you remember from the previous discussion on classes. So, yeah, I'm fanboying over these error messages here. So what else is going on? Here's where it says you can't touch A that is a member of Baz over here either, because it too is private in this context. It's declared here. And it goes on and on and on. It is always is the case. When you get one little simple error, you end up with 900 messages, okay? It's a lot of spew. The way you got to go about this, by the way, if you really want to fix this, is only pay attention to the first one. Just fix that, compile it, and just compile the thing to death. You learn a lot by reading these error messages one at a time. Never go bottom up, because that's usually a warning about an error that's a misinterpretation caused by the earlier errors in your output. So you just want to go through those one at a time from the top down to fix these things. So anyway, as designed, this was supposed to be broken. So really, that's all there is to Friends. It allows you to bypass the security system that's on these objects to allow anything that you grant access to reach in and interact directly with the private parts of a class. Now, you might say, well, why don't you just make them all public? Well, you know, the whole point of private is to be able to have control and knowledge of what is interacting with these variables so that you can always validate their values, make sure they never become invalid. You can check them in your mutator functions. You know, like up inside here. Did the code that called set A give me a value in the correct range? You know, maybe I only allow positive numbers or numbers between 100 and 1,000 or something like that. You can put if then else and stuff in here and generate warnings, or as we'll see down the road, throw exceptions and stuff like that to indicate that a problem has happened. Vastly improve your ability to debug your program when you're running your code. So you don't want to just willy-nilly provide public access to every single thing in any given class. You want to have very tight control over who gets access to the private parts, all right? So there's two kinds of friends. You can say a whole object, a whole class is a friend, or you can one at a time indicate single specific functions like this that may or may not be member functions of a class, okay? So we'll see this in use when we talk about operator overloading down the road. Meanwhile, suffice it to say that you don't want to be too liberal about granting friend access to your classes. As a general rule, I never provide friend access to my classes unless I have to. And the only times I actually have to do it is when I'm dealing with things like operator overloading. And that's a subject of another discussion that we'll see down the road. Thanks for watching. Bye.